Welcome to our session today. I am your instructor, CPA Aringo Frederick. In our last class, my good students, remember, we had introduced the concept of matrices. We looked at the types of matrices. In our session today, I want us to talk about operation of matrices. It will be very important for us to understand the operation of matrices because it will be one of the foundation which will guide us as we go on with the concept of what are matrices. So many times, my good students will find that the following operations can be carried out in matrices. The following operations can be carried out in matrices. Number one, we normally tend to talk about is addition of matrices. Number two, subtraction of matrices. Subtraction of matrices. Number three, very important for us to understand, is multiplication of matrices. Multiplication of matrices. And number four, we should be able to understand which one? Inverse of a matrix. I know majority of you maybe were expecting Mwalimu to say division of a matrix, right? So I'm having inverse of a matrix. So matrix inversion. Matrix inversion, matrix inversion. These are the four talk about operations of our matrices that we'll be looking at: addition, subtraction, multiplication, and inversion of our matrix. So you'll find that addition and subtraction, we are going to handle them at the same time because they have the same concept. Multiplication is also a whole different thing. We're going to handle it separate, and also inversion. So all of these are very simple to understand concepts. So long as you master the concept, you'll find them to be very, very easy. On the four, inversion has a wider concept, which will take us more time compared to the other form of operations. So today's class, my good students, I want us to dwell with addition and subtraction. Let us concentrate on addition and subtraction of matrices. So therefore, let us start with the first one. Addition and the subtraction of our matrices. You are going to look at these two at once, as we've said. Addition and subtraction of matrices. Addition and subtraction of matrices. But before we go deep into dissecting this concept of addition and subtraction of matrices, my good students, it will be very important for us to review what we did earlier on. It is very vital for us to understand the order of matrices. And when you're talking of the order of matrices, my good students, take for example this case. I'm having, say, matrix A. I'm having matrix A. Matrix A, maybe you're having it to be in this form. Talk about maybe 2, 4, 7, 3, for example. On this other case, I'm having this other matrix, say like I'm having, say, matrix that is, of course, maybe 8, 9, 7. Talk about maybe 6, 7, 5. Then this is a matrix B. This is matrix B. Then I'm having matrix C. Matrix C. Maybe I'm having matrix C being represented by, say, like, we can have, say, like 8, 6, maybe 9. Talk about maybe 5, 3, 7. Okay. And also another case here, say matrix D. Matrix D. Maybe we are having this concept whereby I'm having, say, like a 9, 7, 8. Maybe talk about 5, 6, 4. Maybe 3. Talk about 8 and say like 9. These are different matrices with different orders. Matrices with different orders. It will be very vital for us to understand this order of matrices. It is very, very important for us to understand the order of matrices. So let us start with the first one. And I want you guys to always remember the concept of what? Roman Catholic. Always remember the concept of Roman Catholic. Roman Catholic. We are starting with rows, then we go to what? To columns. That's why we are saying Roman Catholic. A very important concept that you should always understand. So we start with rows. By defining the order, we'll always start with the rows. And the concept of Roman Catholic was taught by a very good lecturer of mine. In this case, it will also assist you guys to understand this concept clearly, right? So we are starting with our Roman. So I'm having Roman 1, Roman 2, right? Rows. So row 1, row 2. Column 1, column 2. So we can clearly see at this point I'm having 2 rows and 2 columns. So in this case, we are going to term this as what? 2 by 2 matrix. 2 by 2 matrix, because of the concept of what? Because of its order. We are having 2 rows and we are having 2 columns. Look at matrix B. Roman Catholic. How many Romans do we have in this case? We have Roman 1, Roman 2, Roman 3. So we are talking about 3 rows, right? Whereby you are saying I'm having row 1, row 2, row 3. And how many columns? I'm having column 1 and you're having column 2. So, in other words, in this case, we are talking about 3 rows and 2 columns. So that should give us what? 3 by 2 matrix, with the concept of I'm having 3 rows and 2 columns. So 3 by 2 matrix. Very important concept for us to understand. Proceed to matrix C. What do we have? Matrix C, you can clearly see that how many rows do we have? How many Romans? How many Romans? And how many Catholics? How many Romans and how many Catholics? So we are having how many Romans? Rows, in this case, you're having row 1. In that case, I'm having row 2. And how many columns, my good students? You're having column 1, column 2, and column 3. So confidently we can say that this is an order of, that is how many rows? 2 rows. And how many columns? 3 columns. So 2 by 3 matrix. 2 by 3 matrix. A very important concept for us to understand. What about matrix D? What do we have on matrix D? How many Romans? How many Romans? How many Romans? How many Romans? How many Romans do we have? In this case, we're having how many Romans? In this case, we're talking of rows, right? Row 1, row 2, row 3. And how many columns? In this case, we have how many columns? Catholics? 1, 2, 3. So we can clearly see that in this case, I'm having which order? 3 rows and 3 columns, giving us 3 by 3 matrix. This will be very, very vital for us to understand. Anytime you're talking about the order of matrix, it will be very, very important for us to understand these concepts, my good students. For you to understand and for you to identify, you are dealing with a matrix of which order. You are dealing with a matrix of which order. It will be very, very key for us to understand. Now, let us jump to addition and see what this entails. Anytime you're talking about addition, I want us to see how this will imply, or rather how will we apply addition of matrices. What you must have in mind, both addition and subtraction of matrices. There is no way whereby I'm going to add a matrix with different order. Meaning that I can't add a matrix which is in order of 2 by 2 and we add it to the matrix which is in order of 3 by 2. There is no way that we can add matrices, either adding or subtracting matrices with different orders. That is the one main important rule that you must always understand very well. For us to add or subtract any form of matrix, they must be of the same order. They must be of the same order. And I clearly believe at this point, Mwalimu has explained to us how we are going to identify these orders. The concept of Roman Catholic. The concept of Roman Catholic. So, in this case, you're saying we can't add a matrix with different orders. They must be of the same order. Take, for example, this case. I'm having matrix A here. We are having matrix A here, whereby in this case, you're having 2, 4, 7, 3. Talk about matrix B. I'm having matrix B here. Matrix B, in this case, you can take matrix B of 8, 6, and 9, 7. So, we can clearly see that these two matrices are of the same order. 2 by 2 matrix. Therefore, it means that they are compatible. You can add this matrix. So that in this case, if you're talking of addition of A plus B, adding matrix A and matrix B, that will be very simple because you are having here 2 and 4, 7, 3. We add what? We add 8, 9, and 6, 7. Correct? So how will we add this? This will be very simple because what you are going to do, my good students, are just be taking the first elements you add with the first element of the first matrix. We add with the first element of the second matrix. So whereby you are saying that I'm having the first element which is here. We are adding the first element of the second matrix. So in this case, I'm having 10. 2 plus 8, 10. Proceed to the first one, and clearly you can see we are starting with what? We are starting with our rows. We are starting with our first rows. We are adding our first row, we add it to the first row of the other matrix. The other point, talk of the second element in this row. I'm having 4, and the second element in this matrix, I'm also having what? I'm also having 6. So if we can add them, that should give us what? Just a moment here, my good students. I know you can see Mwalimu on the dark. Just a moment here. So that the other point clearly here we can see, yeah, that is now okay. We are now back. So in this case, you can clearly see that the other bit we can clearly confidently come and take 4 plus 6. Of course, that should give us 10, right? 4 plus 6, that should give us 10. That should give us 10. So that as at the end of the day, what you can do, we proceed to the second row. We take the second row, the first element of the second row, which is 7, we add it to the first element of the second row, which is 9. So I'm having 7 plus 9, that should give us 16, right? 3 plus 7, that should give us 10. So that our matrix will be in this order. Our matrix will be in that order. So that should be our resultant solution if we were to add our first matrix here. And that is what we should have. That is what we should have. Assuming I'm having 3 by 3 matrix. How will you go about it? Assuming I'm having 3 by 3 matrix. In this event, you're saying, assuming I'm having 3 by 3 matrix, whereby I'm having matrix A, take matrix A, take matrix A. I'm having matrix A to be, say, like a 9, 5, 3, 7, 6, 8, 8, 4, 9, right? Then I'm having matrix B here, matrix B. I'm having matrix B to be in the form of, say, like maybe talk about, say, like 10, 12, 6. Then I'm having, say, like 8, 7, 5. Then talk about maybe, say, like 6, 9, 5. Or rather 6, 9, any figure, assuming 8. Okay? So we want to add this matrix. Remember, we said that they must be of the same order. For them to be very compatible, they must be of the same order. And clearly at this point, you can clearly see we're having 3 by 3 matrix. So meaning that if we were to add them, if we were to solve this, I should be having 9 plus 10. That should give us 19. We are starting with the first row. We said 5 plus 8, that should give us 13. 3 plus 6, that should give us 9. Proceed to the other one. 7 plus 12, that should give us 19. 6 plus 7, that should give us a 13. Talk about 8 plus 9, that should give us how much? 17. The other case, I'm having 8 plus 6, 14. 4 plus 5, 9. 9 plus 8, that should give us what? 9 plus 8, that should give us 17. So this will be our matrix. The resultant figure, you can clearly see I'm having what? I'm having 3 by 3 matrix again. I'm having 3 by 3 matrix. That is the most important thing that we should always have at the back of our mind. Understanding this concept of matrix, understanding this concept of matrices. So, after we have handled that bit, that was addition. What about subtraction, my good students? What about subtraction? Subtraction, the same rule applies. Anytime we read about subtraction, the same rule applies. For us to subtract, they must be of the same order. These matrices must be of the same order. They must be of the same order. Consider the first case. Consider the first case here. Consider the first case. I'm having this matrix A and B, where I'm having 2, 7, 4, 3. That's our first matrix. We less 8, 9, 6, 7. Okay? So what will be our resultant figure here? So the same concept will apply. Consider our first row, first of all. The first element in our first row under our first matrix, I'm having 2. The first element under our first row in the second matrix, I'm having 8. So I'm having 2 minus 8. Clearly that should give us negative 6. Right? 4 minus 6, that should give us negative 2. 7 minus 9, that should give us negative 2, correct? 3 minus 7, that should give us negative 4. So that should be our matrix if we were to deduct the same. Clearly you can see we are achieving 2 by 2 matrix. We are achieving 2 by 2 matrix, given the concept that Mwalimu has taught you here, the aspect of what? Identifying the orders, right? What about the second one? The second one, take our same illustration, 9, 5, 3, 7, 6, 8, 8, 4, 9. We are going to add, in this case we are deducting, sorry. So we are talking of 10, 8, 6, 10, 8, 6. We are having 12, 7, 9, 12, 7, 9. And we are having 6, 5, 8, 6, 5, 8. So that if we deduct this, my good students, what will we achieve? We are going to achieve what? 9 minus 10, of course that should give us minus 1. 5 minus 8, that should give us, of course, minus 3. 3 minus 6 should give us minus 3. Proceed to the second row. In this case, I'm having 7 minus, of course, 7 minus 12, that should give us minus 5. 6 minus 7, that should give us minus 1. 8 minus 9, that should give us minus 1, right? We are taking this one minus that, that minus that, that minus that. The third case, the third row, we should be talking of 8 minus 6 to give us negative, or rather to give us 2. 4 minus 5, that should give us negative 1. 9 minus 8, that should give us 1. Okay, that should give us 1. 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 So at this point, you can clearly see what are we achieving. We are achieving a 3 by 3 matrix. We are achieving a 3 by 3 matrix. We are achieving a 3 by 3 matrix. Basically, that's how we can consider, or rather that's how we can look at the concept of addition and subtraction of what? Subtraction of matrices. So, in summary, the first thing and very important concept that you must always have in mind is upon you to understand the order of matrices. And Mwalimu has clearly explained here. We are going with this concept of what? Roman Catholics. Romans, or rather Roman Catholic. Number of rows and number of columns. Romans Catholic, right? So the moment you are able to identify that concept, my good students should find that, The next bit that I'll also want us to talk about, that should be multiplication of matrices, which again, it should be very, very easy for us to understand the concept of multiplication of matrices. So that we are going to handle that in our next class. Thank you so much, and let us meet in our next session. Thank you.